I've saved the best for last. These, by best, I mean my favorites. These are Dietzgen slide rules, and there are 9 of them shown here. I have a few more, but this is pretty much represents the alpha omega, and at one end is a very early rule. It's a fairly simple Mannheim simplex rule. In other words, the scales don't extend on the back, although it does have, we'll see on the back of the slide, down to the first really nice slide rule I ever owned, this Dietzgen 1725 vector log-log slide rule that I bought in 1962. So I'll show you a chart here in a second, but the Dietzgen slide rules were always my personal favorite, and the reason, as you'll see in a little bit, is I felt like Dietzgen put more attention into making a slide rule that worked well rather than one that just looked good. And what I mean by that is everybody moved scales around and used color and other things to enhance their slide rules, and most of it was good. But Dietzgen also worked on the slide mechanism and the cursor in ways that I think made slide rules better. I wish some of the other manufacturers had adopted some of the advances that Dietzgen made. But basically, the Dietzgen rules, perhaps because the first good slide rule I ever owned was a Dietzgen, were always and still are my favorites. So here are the 9 rules that I've picked out to look at today. And the chart is opposite to the way they're arranged on the table. In other words, the 1725 is the one that's at the bottom, and the 1750p is the one that's at the top. But these are arranged in order of catalog number, and the sequence of catalog numbers do not necessarily represent the chronological sequence of when these were introduced. So they vary from a simple, what's called monophase slide rule, which just had the simple Ka, B, C, D, and ST and log scales. It also has a CI scale, up to some fairly complicated vector log-log that include hyperbolic as well as symmetric log-log scales and so on. So let's take a look at the individual rules. But before we do, I thought I would just show you a few pages from the Dietzgen catalog. In the early days, they built Mannheim slide rules and then what they called monophase slide rules, including the Phillips style. And basically these were simplex rules with just a single side to them. This is a Phillips slide rule that from their early catalog. And they also made a variety of other slide rules, but the ones that I'm most interested in are the duplex log-log rules. Next, Dietzgen supplied cases. This is the one that 1725, that it was my first and favorite, came in. They also made a black case, very similar to it, and also a few other styles. In general, by the 60s, all Dietzgen slide rules were being supplied in these kinds of cases, as far as I know. And then the books that they supplied were equally good, in my opinion. Here is one that came with the monophase multiplex. This is the 1735, which you'll see in a moment is similar to the 1725. That was my first good slide rule. Here is the manual from the 1725, and notice that both of these are vector log-log, and so we're going to talk more about these rules when we talk about vector slide rules. But here was probably Dietzgen's most popular rule, the 1732. I think that it probably sold more than any other Dietzgen log-log rule. And notice it's a decimal trig, log-log, so in other words, it measures angles in decimal degrees, not in minutes and seconds. I'll talk about these three rules first. This is a 1746. Then a 1749, and then a 1750. Now, despite being much higher in the sequence, these rules were some of the early slide rules and had basic functions. This one, the 1750 or 1750p, had scales on its slide, but you could only read those from the back, and you may notice there's a cursor here that allowed you to read these scales from the back. These are basically the S&T scale, and allowed you to do sines and tangents, and also cosines by using the complementary angle. This next one is the 1749, which was their Maniphase decimal trig rule. And I'm going to zero in a little bit on the ends of these so that you can see some of the scales. You'll see that it has the typical folded scales, the inverted C folded, the inverted C, and then C, D, and L on this end. On the back, it had K, A, B, T, S, T, S, D, and DI. DI was a little unusual. It was one of the first rules to have a DI scale on it, and it was a very useful, though not a log-log rule. In other words, it worked very well for most basic mathematical operations, including trig. This is the 1746, which is called the Maniphase multiplex rule, and the scales on this side are, once again, the folded scales, the CIF, the CI, and the C, as well as D and L, very much like the one we just saw. And on the reverse side, you notice that we have the first log-log, I'm sorry, I apologize. We have the standard A, B, S and T, sine and tangent, as well as D and K. K, of course, being the cube root scale, and A and B being the square root or square scales. So that is the 1746. I think I told you, yeah, this is the 1746. And then the 1749 and the 1750. And those were the relatively, those are the oldest Dietzgen slide rules that I own, and they represent kind of the early era. This is the 1731, and you may notice up here it says it has the micromatic adjustment. And what they're referring to is this this screw that you could turn here, which basically adjusted the tension between the slide and the body of the rule. This was a unique feature, and it was one of those things that, as I told you, Dietzgen put a lot of time and effort into trying to make their rules easier to use. That is, the slides to move more easily and so on. The 1731 is pretty much a full log-log rule. It contains the log-log scales, or basically 1 over e to the x, which is, in other words, exponents, x exponents to the power less than 1. And then the corresponding scales down here for exponents greater than 1. And then in between are the standard folded scales and the CIF and scales. This one is a little bit unique in that it has the L scale on the slide. That's not too often that you see that, but it is sometimes pretty useful. On the back of the 1731 are the ST 2 tangent scales. That's a little bit unique. Generally, most of them only had tangent scales up to 45. This one has a tangent scale that goes from 45 on up. Also has the K and AB scales and the D scale. But then it has a log 1 and a log 01 to extend the exponential or log features a little bit. Before I leave the 1731, I should point out that, as you can see here, the degrees on the sine and tangent scales are in minutes and seconds, not in decimals of degrees. And that contrasts with the 1732, which is a decimal trig rule. They've also added another LL a 00 scale on the same side with the LL0 scale, and then the DI scale and a K on this side, along with the trig scales. The other side is a little bit unique in that it has the L scale along with the LL1 scale, and then the LL2 and LL3 scales down here, and then the folded scales and the C and D scales. So that's the 1732, which was the successor to the 1731. Here now is the 1733, which, as you'll notice, has a pair of log O scales, that is the O2 and O3 scales for numbers, exponents less than 1. And at the bottom, the corresponding or symmetric scales that also for exponents greater than 1. Then the folded scales, an L scale on the slide, a CI, and then C and D. On the reverse side, you see that this is a decimal trig rule. It has a K and an A, as well as the B, and then the trig scales and a D. Beneath it is a DI scale. Dietzgen put DI scales on almost all their rules, at least their log duplex rules. And then beneath it is the LL1 and the corresponding LL01 scale up above it for exponents greater than 1 and less than 1, respectively. And now the 1734, which looks very, very much like the 1733 that you just saw. I won't read the scales to you. They're fundamentally the same. On this side, it's also fairly much the same. That is, it has the LL01 and the LL1, and then KAB, 2 tangent scales, an ST, an S, and a D. So what's the difference between this rule and the 1733? Well, the 34 introduced a new feature called microglide. If it'll focus here, you'll be able to see right here are some Teflon inserts that make the rule one of the smoothest slide rules you'll ever use. And if you ever use a microglide by Dietzgen, you'll wish that everybody had adopted this. Those Teflon grooves really make a difference in making the rule slide freely and still stay in place, because it's important that once you make a setting, you want it to stay there. And So they not only slid easily, they didn't have to be readjusted, at least not very often, for temperature and humidity, which almost all the other rules did. So the 1734 was the first microglide rule. Now I'm going to take a look at the 1725, which is the one here at the top, and the 1735, which is this one, together. And the reason I do that is these are two vector log-log rules. I'm going to look at the 35 first because even though its number is higher than the 25, it actually preceded the 25. So just as the 34, it has log and then LL1, and then the folded scales, and then LL3 and LL2. Notice that all of the positive logs, in other words, those with exponent greater than 1, are on one side of the rule. On the other side of the rule are all of the logs that are greater, that are less than 1. But uniquely for Dietzgen, this is the only rule I know of where Dietzgen put the log-log scales for values less than 1 and paired them with the A and B scales instead of with the D scale. In addition, you may notice that it has the standard A, B, T, S, T, S, D, and then 3 new scales. TH, which is hyperbolic tangent, SH2, which is hyperbolic sine number 2, and SH1. It's these special scales that give the 1735 the designation of a vector slide rule. And in a subsequent video, I hope to talk about what that really means. Now back to the 1725, and you'll notice that on this rule, those hyperbolic scales are now above the slide on the body, hyperbolic tangent, hyperbolic sine 1 and 2, and then AB, 2 tangent scales, S, T, S, D, DI, and K. And then on the other side of the rule, they made a change, and they now have put all of the log-log scales on one side of the rule. Notice these are for numbers less than 1, these are for exponents greater than 1, and then in between are the DF folded scales, CIF, L a little bit unique on the slide, although they've done that before, the CI, the C, and D scale. So in a future video, I hope to be able to talk about these hyperbolic scales and their use, particularly in electrical engineering. They come into play in mechanical engineering and a few other places as well, but in electrical engineering, particularly for long transmission lines, the hyperbolic functions are a very useful way of characterizing, or at least computing, the characteristics of long transmission lines. So I hope to get into that in a future video. But in the meantime, I hope you've enjoyed this overview of Dietzgen slide rules, and look forward maybe to that vector, though I will tell you that hyperbolic functions can get a little bit turgid, and there's a lot of well, let's just say misunderstanding, even among educators and practicing engineers. But we'll get into that in a future video. In the meantime, have a nice day.